Okay, let's take a look at the math behind the scenes here. In this case, if you want to think of this as drawing one starburst first and seeing what that is, the probability of getting a red on that first is 1/4. On your second starburst, the probability of getting a red is also 1/4. Now, if this is bothering you and you're thinking, well, that's not what we did. We opened a package and there were 2 starbursts. I don't want to deal with it one at a time. I would encourage you to skip ahead in the video to this slide. The pack is an independent event. I think this you can start here and then go back and watch the other video. What happens here is we can think about this. We can think about, okay, well, let's actually look at it. Let's just say we got a red on the first try, an orange on the second try. That's not what I mean. Sorry. Let's say we look at that first starburst in the package. What colors could it be? It could be red, it could be orange, it could be yellow, and it could be pink. What about the second starburst? Well, the second starburst could also be red, or I could have a red and the second starburst could be an orange. It could be a red and the second starburst a yellow. The first could be red and the second could be pink. So there's 4 possibilities if red is the first choice. And then I can just repeat this thinking. If the first one was orange, the second one could be red, or it could be orange, sorry. It could be yellow, or it could be pink. So if the first one was orange, there's 4 possibilities for the second starburst. I'm going to do that for yellow. I could have a yellow for the first one and a red for the second one. But I could have a yellow, orange, yellow, 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 pink. And the same way with the pink, you could then have a second one be the red. You could have a pink and an orange, a pink and a yellow, and a pink and a pink. And in this case, if you think this through, you can see there's 16 possibilities. And of these 16, you see we get red starburst in these packages. We also get red starburst in these packages. So the probability of getting a red is equal to 7 out of 16. If you count them up, 1, 2, 3, 4, 5, 6, 7 out of 16 total. Now, you might ask yourself, is there a shortcut? And there is. It's actually not necessarily part of this class, and it's okay to skip this if you want. But the shortcut is to think about what's the probability of getting a red on the first one, plus the probability of getting a red in the second one. But then we have to subtract the probability of getting 2 reds. Okay. And the reason that is, if you look in the table, if you see the probability of getting a red on the first one, we see it's 1 out of 4. We already knew that when we started. I'll just use green. Plus, what's the probability of getting red on the second one? Well, if you look here, the probability of getting red on the second one is also 1 out of 4. But you'll notice we've counted this one twice. And so to make up for that, we have to think about what's the probability of getting 2 reds. And this is where that 1/4 times 1/4 comes in at. I won't go into the details now. But if we take 1/4 plus 1/4 and we subtract a 16th, we get 7/16. And so several ways of finding it here, but this is looking at both events as an independent event. Like I said, if this bothers you to think about it this way, that's completely fine. It doesn't quite match what we did in real life. I would agree with you. So let's take a look at that scenario. Let's say that we want to think of each pack as an independent event, okay? If you think of each pack as an independent event where you just open a package and it's either orange, yellow, or yellow, yellow, or pink, red, and you're not going to break it up and think about the first one and the second one, then we have to go back to this chart. And I'm not going to go into the details here. You'll just have to trust me on this. That's not a very good color to use. Let's see. Can you see this better? There we go. To get a pink yellow, the probability of getting a pink yellow, or called a yellow pink, we're treating these two as the same. The issue is the probability of that is twice as likely as getting a yellow yellow. Okay, and you can see it here for some cases. Okay, you can see it here. You could see theoretically it's about twice as much. Now, it does break down, right? So I've got a few places like here. It looks like it's equally likely, doesn't it? But you'll just have to trust me on this, that it's twice as likely to get a mixed color as it is two of the same. So I'm actually going to come back here and steal this. So if we're going to do that, I think I can do that, yeah. We have to recognize that this one, this one, this one, this one, this one, this one, these are all twice as likely. I was going to write twice with a 2 in it. Twice as likely to occur compared to this. And so when we were looking at going back to our spinners for a second, if you think about a spinner that's twice as likely to happen, one way to do that is think of it as showing up twice in our spinner. And so when I list these out, if I think red pink is going to happen twice as likely, red yellow is going to happen twice as likely, red orange is going to happen twice as likely than red. Do you see how I've now made this column so that everything is happening twice as much as this one? And you can probably see where this is going. Orange pink is going to happen twice as likely. Orange yellow is going to happen twice as likely than orange orange. Yellow pink is going to happen twice as likely compared to yellow yellow and pink pink. And so if we take a look, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total possibilities. And of those 16, guess how many are red? 1, 2, 3, 4, 5, 6, 7 out of the 16 are red. And so the probability of getting a red starburst out of a pack of 2, in theory, is 7 out of 16. Now, in one of my classes one time, we started opening them. The first person got 2 pinks. The second person got 2 pinks. The third person got 2 pinks. The fourth person got 2 pinks. The fifth person got 2 pinks. What do you think the probability of the next person getting 2 pinks was? I'm guessing it was about 100%. And it was. We opened for the entire class of like 20 students, and everyone had 2 pinks. And so that's why we call it theoretical probability, where each has an equally likely chance of appearing. So I hope you've enjoyed